Well, greetings everybody. So this video is a follow-up to my last one, which was about the order of operations. But this time I'll be talking about the order of operations and how we think about algebra. So first of all, maybe tell you a little bit about what algebra is. You could say it's how we do math with numbers that we don't know or are changing. So I could say the numbers are unknown or variable. If we don't know a number, we can't write a number down. We have to use a letter of the alphabet to stand in for it. Okay, X, Y, Z, A, B, C, or whatever letter of the alphabet you want. Sometimes numbers are variable. They can take many different values. And so because they're not any one value, we can't write down a number for them. And again, we use a letter to stand in for them in that case. So if there's a number that we're working with and we either don't know it at the moment or it could change, we let a letter represent it. That's what algebra is. It's learning how to do math with numbers that we don't know or could be changing. Okay? So in these problems, you see these expressions, I guess that's what you could call that, where it has letters of the alphabet. This one says 2 times x times z subtract 3 times x. So it is math. It's got multiplication in it, it's got subtraction, but those numbers x and z we either might not know at the moment or they could change. Okay? Now we're given that, but then it tells us, all right, what would this thing be if you knew all of a sudden that x was 2 and z was 5? Okay? So here's the objective with that sort of thing. The goal is to substitute the 2 for the x and the 5 for the z in this expression and then calculate it. But when we calculate it, we need to follow the right order of operations. I already made that video on the order of operations, so if you didn't know what the order of operations was, you'd either have to learn it to follow this or go back and look at that other video. So I'm going to do that. I'm going to take this expression, 2 times x times z, subtract 3 times x, and I'm going to let x be 2 and z be 5. And notice here I've done that. I've left the original numbers 2, 3, and the minus in my black pen, and I put the x and z with red to show you that I put those in. I substituted those. Okay? So now it's just a matter, now that I've done that, of calculating this. What is 2 times 5 subtract 3 times 2? Well, we follow the order of operations. The order of operations would say we do multiplications from left to right. So I do 2 times 2, I get 4. Then 4 times 5, I get 20. Then 3 times 2, I get 6. And then at that point, after I've done the multiplications from left to right, the only thing left is subtraction. I get 20 minus 6. I get 14, and I'm done at that point. My answer is 14. So that's one thing that we can learn to do when we're learning algebra. Okay? Really, you just have to know the order of operations and realize that we're substituting these numbers in for those letters. Okay? So let's try another one. Now, I included this one because it seems to look a little bit different. All right? It says C, some unknown, unspecified number, is w plus 3 to the second power. And it says, well, I guess you could say this one saying, what do you get when you let w be 3? Our other one didn't say like C equals. It just gave us this expression. We put our numbers into it and we calculated. But all this one's saying is, well, if you put 3 for w and you did all the math that's there, what result would you get? That's your answer. Okay. So, all right, let's say I've got C, which is some number I don't happen to know at the moment, is w plus 3 squared. But w, it says, is supposed to be 3. So we'll put 3 for that w. All right, we get 3 plus 3 to the second power. How do we do that? What's the order of operations say? Well, in the order of operations, we always complete what's in a parentheses first. So I've got the exponent right there of 2, but I'm going to have to figure out what 3 plus 3 is first. 3 plus 3 is 6. Okay, now if that's done, I take care of the exponent. What's 6 to the second power? What is 6 times 6? It's 36. 36 is our answer. Okay, so let's look at it more. What about this one? This one's got fractions in it. I see this as 12 times x, then divided by y. Subtract 12 divided by y. What do I do there? Well, it says let x be 2 and y be 6, right? So there's our original problem. And within that, as you see it, I'll let x be 2 and y be 6, which you see here. Now, what order of operations should I follow? Well, I need to figure out what this top part of the fraction is first. 12 times 2, that's 24. And then what do I have left? I got 24 divided by 6, subtract. 12 divided by 6. Do you subtract? Do you divide? How's that work? Well, according to the order of operations, we divide from left to right before we subtract. 24 divided by 6 is 4. Then 12 divided by 6 is 2. Then 4 subtract 2 is 2. And we're done. So let's look at one more like this, and then we'll see something that's a little bit different. What about x to the second power, subtract 3 times x, then plus 8? What's that going to be if you let the x be 6? Okay, well, I'll take that formula, that expression, I'll take that. I'll let x be 6, which would look like this, wouldn't it? So once again, on all these problems, I'm leaving this original formula and writing that in black ink, and I'm letting the number that I substitute be in red, just so that you can see it's all there. So it helps you to see that pattern, to understand it, and then that's why I'm doing it. So what's next? So I've got an exponent. I got 6 to the exponent 2. I've got subtraction. I've got addition. I've got 3 times 6. I've got multiplication. What do I do out of all that? What comes first? Well, the order of operations would tell us the exponent comes before multiplying, addition, and subtraction. So first I got to figure out what's 6 squared. 36. 6 to the second power is 6 times 6 is 36. What's next? Subtraction, addition, multiplication. Multiplication's next. What's 3 times 6? It's 18. Now I have subtraction and addition. In between those, I'm supposed to do those as I see them from left to right in the formula. So I got to do 36 subtract 18. That's 18. But then plus 8, that's 26. 26 is our answer. Okay, so one last problem. Now, this one looks different than the others. It really does. And they say that this thing is called a function. Okay? So it does seem different. And the way I would read this notation, see this where it says like the letter f of parentheses -1? That says f of -1. What you can think of that as is it's asking you, what happens when you let -1 be x in this formula? In this next one, I might read that as f of 0. What that says is, what does this formula give you when you let x be 0? So you could think of it like when we write the f and then we put a number in there. Just means that for this formula that we started with, that we were given, what do you get if you put this number, whatever that number is, in for x, and then calculate? So I guess in that way, when you think about it, it's no different than others. I'm given some formula and I put some number in for x. Okay? Or if I don't have an x, if I've got some other letter of the alphabet, I put the number in accordingly. All right? So that's what this one's saying. Now just look how this is what I was originally given. X here is going to be some number that's given in the problem, and then the x in the formula, you put that number in for it and you do the math. So f of -1 means in this formula we will put -1. That would look like this. Now I have an exponent of 2, and then I'm adding. What do I do first between those? Exponent or add? Exponents will be before adding. So I got to do -1 to the second power, which is 1, and then I do 1 plus 5, which is 6. Okay, so 6 is my answer. When I put -1 into that formula and I do the math, I follow the order of operations, I get 6. Okay? Now, real quick about the exponent. Did you know -1 to the second power is 1? Why is that? Well, what do exponents mean? If I say -1 with an exponent of 2, it means I multiply -1 by itself 2 times. That's -1 times -1. And a negative times a negative is a positive. and 1 times 1 is 1. Just by comparison real quick, if I happen to have negative 1 to the third power, I don't have that here, but if I did, then it would be multiply negative 1 by itself 3 times, which is negative 1 times negative 1 times negative 1. And if you do these multiplications one at a time, you'll get negative 1 as a final result. Okay? So let's look at part B of this one real quick. What's f of 0? So that would mean, in that formula right there, x to the second power plus 5. What would you get if you put 0 for the x and you calculate it? Okay, so f of 0 means, okay, x squared plus 5. That's my formula. But I'm going to put 0 for the x. And I'm going to do 0 squared plus 5. All right, exponents first. What's 0 to the second power? 0 to the second power means 0 times 0, which is 0. Now I have 0 plus 5. Okay, 0 plus 5 is just 5. All right, so here hopefully you see, like I showed you, different problems. They all looked a little bit different than each other. Okay, no two were exactly like, but they had this same theme every time. I'm given some kind of formula. It has letters in it. I put letters, numbers in for those letters according to whatever the instructions on the problem were, and I do the calculations, and that's all there is to it.